Okay, so today we're going to look at quadratic equations and quadratic expressions, and eventually we should get to the point where we should be able to sketch quadratics. So let's have a look. A quadratic looks like this. It's got ax squared plus bx plus c, and I've got a bit of new notation here for you which you've never seen before. And it says where a, b and c are real numbers, that's okay, but this bit here, all it means is where a, b and c, and this little symbol here means belongs to. So what we're saying is where a, b and c belongs to, and then this funny r here is just the set of all real numbers. So all we're saying is a, b and c belong to the set of all real numbers. In other words, a, b and c are a real number. Now, you're thinking, what's a real number? A real number is any number. It can be a decimal, it can be a surd, it can be pi. And the only reason why we call them real numbers is because if you go into high levels of maths, we introduce this thing called imaginary numbers. Okay, so as far as we're concerned, a real number is any number. Okay, so as I've done before, we're going to look at factorising quadratics. 3 different main types that you can factorise, or usually you can factorise. And we've got the one where we've got an x squared term, an x term, and a constant term on the end. And these are the ones that you recognise most frequently as quadratic equations, okay, or quadratic expressions. So how do we factorise them? Well, we need to find a number that multiplies to make minus 15, and we need to find a number that adds to make plus 2. So what I tend to do is just go down the factors and do it quite systematically. I go 1, 15, 2 doesn't go into it, 3 and 5, and there we go, we've got the 3 and the 5. So we want to have a minus 3 and a plus 5, because they would then add to make plus 2. And then because it is a single x squared, we can then just say my bracket is x minus 3 and my second bracket is x plus 5. Okay, it's always a good idea when you first do these and when you're first practicing them is to multiply it out. So quickly on the side, I use the grid method to multiply out brackets. So I've got x minus 3, x plus 5, x squared minus 3x plus 5x and minus 15. Put the x's together and you get your x squared plus 2x minus 15. Tick, it's worked. Okay. So that's the first type where you've got an x squared, an x and a constant term. Right, next type, we have no constant on the end. Okay, and this is the one that pupils get mixed up the most, I think. No constant. Because you could think it's a double bracket because it's a quadratic expression. And if you did go along those lines, you'd say, well, I want 2 numbers that multiply to make 0 and add to make 3. Well, it's just going to be 0 and 3, because any number times 0 makes 0. And you'd end up with the brackets x plus 3 and x plus 0. But there's just no point in writing x plus 0, so we don't write it like that. What we just do is we recognise this type of quadratic and we say we take out a factor of x and then you have x plus 3, okay? And the last one, which unfortunately I've lost a little squared on, is the x squared minus 9. Now this one has got no x term and it only works if it is a subtraction. Okay, so this only works if you're subtracting the constant, and this one has a very special name. It's called the difference of 2 squares, and we learned this in GCSE. It's the 2 brackets again, and we have x plus 3 and x minus 3. Okay, so you need to think what times itself makes the first term and what times itself makes the second term. Right, so they're the three types of quadratics. All three terms, no constant, no x term. But of course, as we know from GCSE, they get a bit more complicated when the coefficient of x squared isn't 1. So as soon as the coefficient of x squared isn't 1, it gets a lot more complicated. Now, some people can do these by what we call by inspection. So they'll just try things. So they might try a 3x and a 2x there, and they might try a 1 and a 12 there and see if it works, okay? But there is a method that you can use where you don't have to do inspection, and really inspection is just a form of trial and error. But there is a method that you can use. And the way I set this out is I use the reverse of the grid method. I showed you a second ago how I use grid method to expand brackets. Well, I sort of use a reverse method to factorise. And so what I do is I draw my grid. And I know in this top corner here, I always had the answer to my x squared term. So in the top corner there has to go my 6x squared. When I expanded brackets, I know in this bottom corner, I always had the constant term because it's always a constant times the constant makes the constant. So I know that the 12 goes in there. And I also know that these two terms made my 17x because the two terms added to make this one here. And I am going to include the plus because the sign in front does matter. And the only thing I've got to work out really is how to split that 17x, because I could do a 16x and an x. It might work, but it might not. I could do a 4x and a 13x. And again, that might work and it might not. So there is a way to work out how to do it. And what we do is we take the 6 and the 12, these two numbers here, and we multiply them together and I get 72. And this is what the two numbers have to multiply to make. They have to multiply to make 72 and they have to add to make 17. So again, I'm going to go through the process. 1 and 72, 2, 36, no. 3 and 24, no. 4 and 18, no. So 5 doesn't go in. 6 and 12, no. So does 7 go in? No. 8, oops, sorry. So I've got 8 and 9, and there we go. That's the one I want. And that tells me how to split this 17x. So I want an 8x and I want a 9x. Actually, let me try and get rid of some of this stuff now. Okay. So that's what I want. I want to split it as an 8x and a 9x. And then I think I am going to take out a common factor of this row. So I've got my 6x squared and my 8x. What's the highest common factor that I can take out of those two? Well, with the 6 and the 8, I've got a factor of 2. And I've got an x squared and an x, so I can have a factor of x. So I can take out a factor of 2x. And this is where we then start filling in the rest. This, oops, not that one, sorry. 2x. I know this multiplied by this makes this. So what times 2x makes 6x squared? And the answer is 3x. I know this times this makes this. So what times 2x makes 8x? The answer is 4. I know this times this makes this. So 3x times what makes 9x? And the answer is 3. And then this is then my check. Because in theory, 3 times 4 should make 12. It does make 12. So I haven't made a mistake. So my factorised version is 2x plus 3 multiplied by 3x plus 4. Okay, right, I'm going to do one more example. So again, I'm going to start with my grid. I know my 4x squared goes in the top left. My minus 36 goes in the bottom right. Then my two numbers have to multiply to make minus 144, because that's what 4 times minus 36 is. And they've got to add to make 45. Doesn't look particularly nice, but let's do the factors. 1 and 144, 2 and 72. 3 does go into it, and I'm just going to do it on my calculator. And I've got 3 and 48, and there we go. That's the one I want. Okay, so it's got to add to make plus 45, so I need to have a minus 3 and a plus 48. And as I said before, this tells me how to divide my 45x. So I'm going to put my 48x there and my minus 3x there. Doesn't matter. In fact, I'm going to prove to you it doesn't matter, because I'm going to do it the other way round down here. So down here I'm going to do it the opposite way. So we're going to put the minus 3x there, and I'm going to put the 48x there. So let's go back to the original one. So want to take out a common factor from them, the highest common factor that I can take out. Well, I can definitely take out a factor of x, because I've got an x squared and an x. Highest common factor of 4 and 48 is 4. So this multiplied by this makes 4x squared, so that must just be x. This multiplied by this makes minus 3x, so this must be minus 3. 4x times this makes 48x, so that must just be 12. And then let's do my check. 12 times minus 3 makes minus 36. Yeah, so my two brackets are 4x minus 3 and x plus 12. Right, let's do it the other way. Let's see if it works. It should do. So again, I'm going to take out the highest common factor of that top row. Well, in this case, 4 and 3 don't have a highest common factor. Well, they do. It's just 1, but that's meaningless. There's no point in putting 1 there. So the only common factor is x. So again, this times this makes 4x squared. So I've got 4x on the top. What times 4x makes 48x is going to be 12. What times x makes minus 3x is going to be minus 3. And then I do my check. Minus 3 times 12 is minus 36, yes. And my two brackets are 4x minus 3 and x plus 12. Okay, so doesn't matter which way you put it round. All right. Right, here we go. I've got about 5 feet to have a go at. Do the usual, press pause and see if you can factorise these for me, please. Okay, so number 1, no constant terms. So we just take out a highest common factor and have a single bracket. Now in this case, we can see we can take out a factor of 3 as well as the x. Number 2 was the more complicated quadratic with all 3 terms. Okay, as you can see, the numbers can get a bit big, but just be systematic when you're going through your factors and you will get there in the end. Right, number 3 was a difference of 2 squares because there was no x term and there was a subtraction, so I could do that one. Number 4, again, normal quadratic, it's just it hasn't got a x squared coefficient of 1. So again, a little bit more complicated, but still okay to do. And the last one was another difference of 2 squares, but this time you have to think what times itself makes 9x squared. So that's got to be 3x times 3x. Okay, so what we're going to look at now, and the main purpose of today's lesson, is to look at how we can sketch quadratic curves. Okay, And I'm going to show you 6 really quick sketches because they're all different situations. And we could have a quadratic that looks like this. And we could have a quadratic that looks like this. Now these are very similar because they both have 2 points where they cross the x-axis. So they have 2 x interceptions. Okay, but this is what we call a positive quadratic, and this is what we call a negative quadratic. Okay, so positives we tend to say look like U shapes, and negatives look a little bit more like an N shape, but they both have 2 points where they cross the x-axis, and obviously a point where they cross the y-axis. Now, positive quadratics always start x squared with a positive x squared. So an example, this could be x squared plus 3x plus 4. Actually, it'd be minus 3x. And it would be plus 2 on the end, something like that. Okay. Now, a negative quadratic might look like 6 minus 5x minus x squared. Okay, so you'd have the minus in front of the x squared. Whether it's a positive or a negative quadratic is always denoted by the sign of the x squared. Okay, so we could have 2 where they both cross at 2 places. Sometimes we have quadratics that look like this where they just touch the x-axis. And again, we can have a positive and a negative one. Okay, so that has 1 point on the x-axis. And I'll explain how we know what those are. And then the last type is we can have quadratics that actually never cross the x-axis at all. And what we'll do is we'll learn next lesson how to sketch these a little bit better. But how am I going to sketch a quadratic? I'm given a quadratic like this, y equals x squared minus 3x minus 10. Well, can we remember what we did when we had straight lines? We said on the x-axis, no, I'll do the y-axis first, sorry. On the y-axis, the x is 0. Well, I can do exactly the same here. So on the y-axis, x is 0. So I just put in 0 for my x. So I've got 0 squared minus 3 lots of 0 minus 10. So guess what? My y-intercept is just that number on the end, the constant on the end. What I can do for the x-axis, so on the x-axis, I set my y to be 0. So when I do this, I say 0 equals x squared minus 3x minus 10. And this is where that practicing of quadratics comes in. Because what I've got to try and do is I've got to try and factorise. Not all quadratics factorise, so you might have to go back to your quadratic formula, but it's a better skill to try and remember how to factorise. So I'll just scroll up. Again, it's a single x squared, so this is the slightly easier one. So I need 2 numbers that multiply to make minus 10, add to make minus 3, 1, 10, 2 and 5. There we go, it's a 2 and the 5. And this time it wants to be plus 2 and minus 5. So 0 equals, now I'm solving an equation, so I still need to keep putting that 0 equals in. Don't forget to write that. So we've got x plus 2 and x minus 5. Now, what does this mean? This means this bracket multiplied by this bracket. And if we think about how we can have 2 things multiplied together to make 0, the only way that can happen is if one of them is 0. For instance, 0 times 100 is 0. 1,000,000 times 0 is 0. Minus 57.365 times 0 is 0. One of them has to be 0. So this is where we say either x plus 2 is 0 or x minus 5 is 0. And if we then solve that, we get x equals minus 2 or x equals 5. So these are the 2 points where it crosses the x-axis. So let's do my sketch. Not a brilliant axis, but it doesn't matter. There's my 5. There's my -2. If you remember, if we go back up here, we were told it crossed the y-axis at -10. So I'm going to put my -10 down here. Now, the biggest thing to remember is the lowest point of your quadratic is going to be halfway between this -2 and this 5. So you want to visualize where that is and maybe pop it on, okay? It's not going to be necessarily where it crosses the y-axis. It's halfway between those two because quadratic curves are always symmetrical. So when I then draw my curve, I know it's going to come down. It's probably going to come a bit lower and then start going up again. Not very brilliant that, but I'll try it again. So it's going to come a bit lower and then start curling up. Okay? Right, let's have a go at this one. Now then, before we start this one, you should note that this has got a negative x squared. So that means it's going to be an upside down quadratic, an N-shaped quadratic. But same process applies. So on the y-axis, x is 0, so y is going to be 6, because 11 lots of 0 and -2 lots of 0 squared is 0. So on the x-axis, y is 0, so we'll get 0 equals 6 plus 11x minus 2x squared. Now personally, I never factorise negative quadratics, so what I would do is I would add the 2x squared to both sides, I'd take the 11x from both sides, and I'd take away the 6 from both sides, and I'd end up with 2x squared minus 11x minus 6 equals 0. And I'm only changing that because I'm solving an equation. Okay, because it is equal to 0, I can do that. Right, here's my slightly longer process for this one. So I need two numbers that multiply to make -12, and they add to make -11. Well, 1 and 12 is going to work, and it's going to be -12 and 1. So remember, this is my grid method now. 2x squared in the top left, minus 6 in the bottom right, and I'm going to put the x and the -12x like that. Let's factorise that top row. Well, I can only take out a factor of x. Let's go to that top first column. That's going to be 2x. 2x times something makes -12, so that's going to be -6. And x times 1 makes x. So what do I end up with? I end up with x minus 6 multiplied by 2x plus 1 equals 0. So again, the only way I can have two things multiplied together to make 0 is if either one of them is 0. So either x minus 6 equals 0 or 2x plus 1 equals 0. First one's easy to solve. X is 6. Second one, it's an equation again. You've got to solve it. So I've got to do that. Take away 1 from both sides. So I get 2x equals -1 and then divide by 2 both sides. So I get x equals -1/2. And now I can try and sketch it. So what colour shall I use? I'll use blue for my axes this time to make it a bit different. My x is at 6 and it is at -1/2. Right, where did it say it crossed the y-axis? It crossed the y-axis at 6. So I'm going to put that about there. Remember what I said about the fact that the highest point is halfway. So think about where halfway is. So it's going to go a bit higher than that 6. Okay, so let's get rid of that. And here we go. Let's try and draw this reasonably well. Again, we know it's going to be a U shape. It's going to go a bit higher and come back down again. And there is my negative quadratic. Okay. Right. I'm not going to do the one on the right-hand side, but let's quickly do the left-hand side. So again, on the x-axis, y equals 0. Now this is a bit of a different one actually, because you can factorise and say, well, that's a difference of 2 squares, so I know that's 3x minus 5 and 3x plus 5. So either 3x minus 5 equals 0 or 3x plus 5 equals 0. So 3x equals 5, so x is 5/3. Or 3x is minus 5, so x is minus 5/3. But there is a slightly different way of doing this, because if I go back to this point here, if I look, I could just try and solve this. So I could add 25 to both sides, so I'd get 25 equals 9x squared. I could divide by 9, so I'd have 25 over 9 equals x squared. Square root both sides, so I'd have 25 over 9 equals x. But you've got to remember that needs to be plus or minus, because of this fact that when you square root something, your answer can be positive or negative. And actually then you would get the same answer, because you get x is plus or minus 5/3. So you've got both of the solutions, but in a slightly different way. I was going to say quicker, but I don't think it is necessarily quicker. So we know where it crosses the x-axis. We can set on the y-axis x equals 0. So y is going to be 9 lots of 0 squared minus 25, which is just minus 25. Oops, don't know why I wrote 12. And then we can plot it 5/3 and minus 5/3, and it crosses at minus 25. And so it's just going to be a quadratic that looks like that. And this time, the lowest point is at minus 25, but only because that is halfway between your minus 5/3 and 5/3. Okay. And the final one I'm actually going to do is this one on the right hand side, because sometimes they will give you an equation where it has already been factorised for you. But again, the process is the same. So again, we can say on the x-axis, y equals 0. So I'll get 0 equals 4 minus x, x plus 3. Now it's already been factorised for me, so I can say either 4 minus x is 0 or x plus 3 equals 0. So I get x is 4 or x is minus 3. And on the y-axis, I can say x equals 0. So y equals 4 minus 0, again, because I'm just substituting this x equals 0 in, 0 plus 3. Well, 4 minus 0 is 4, and 0 plus 3 is 3. So I'm left with y is 4 times 3, which is 12. And the only other thing to think about this is you could then plot the points, and you know, well, y is crossing at 12, the x was at 4 and minus 3, and that probably tells you what type of shape it's going to be, because there's no way to try and fit that in because of the fact that it crosses y-axis at 12. You know it has to be one of these, an N shape. Oops. But actually you could see that, because when you do the expansion of those two, you're going to get minus x squared. So it's going to be a negative quadratic, okay? But the points sort of indicate where it is anyway. Okay, have a go at those 8, or as many of those 8 as you want. When you've done, press pause, have a go. When you've done, I'll show you the solutions. Okay, so first one crosses the y-axis as 8, and the x-axis at minus 4 and minus 2. So when you sketch it, it's going to look like that. The second one, these was two fairly straightforward quadratics, crosses the y-axis at 9, and the x-axis at -3. Actually, I don't think I did one of these with you. So what does that look like? Well, if it crosses the y-axis at -3 and it almost does it twice, you imagine that it goes through the axis and then comes straight back out again. So that's when it just touches, okay? And we call that a repeated solution because it was x plus 3 twice. So you almost had it's either x minus 3 or x minus 3. So it was a repeated solution. And in that case, it just touches the axes. Okay? So we had a difference of 2 squares, one. So we could see that it crossed at the x-axis at plus and minus 5 and the y-axis at minus 25. Slightly more complicated quadratic with the three terms. Okay, the only thing to make sure is after you factorise with this one, you obviously get this. So solving this part of the equation is a little bit more complicated. Biggest common mistake is people accidentally write that fraction the wrong way round, so just be careful when you're solving that part of the equation. And you should have got a quadratic that looked like that. Okay, so again, number 5, one of these quadratics where there's no constant on the ends. So when you factorise it, you just take out that common factor. Okay, so you get 3x bracket x minus 3. So either 3x equals 0, which means x equals 0, or x minus 3 equals 0. Okay? And on the other side, this time, we have to know we've got this negative quadratic, so we know it's going to be an N shape. But again, follow the same process. And I don't know why I drew it that way, because I should have drawn it the other way. So I'm going to correct myself, because I'm going to put the 18 there. And I'm going to get rid of that. And I'm going to get rid of that. That was me scrolling up and not looking properly. And so my quadratic should have looked like that. And the last two, it was already factorised for you. We know it's going to be a positive quadratic because this times this is going to make x squared. And so we end up with a curve that looks like this. And the last one, again, it was already factorised. But when we look at this, we're going to get a minus x squared. So we know we're going to get a negative quadratic. Everything else is the same though. And so it should have looked like that. Okay, what I'd like you to do now is have a go at the worksheet that is in Edmodo, and I will see you next lesson.